Inductive reasoning is what?
What?
What's inductive reasoning?
Is making a conjecture by what evidence you have.
By observations and looking at patterns, right? Is our inductive reasoning. So now what we're going to be getting into today is deductive reasoning. And deductive reasoning is where you use laws to come up with conclusions. And what do you guys have Mr. Edgar right now in English?
I had him last year.
He was in the faculty room and he was saying how he uses the law of syllogism in his class. So, we're getting...
he doesn't.
Yeah. All right, so our first one, look at that. Law of detachment. Yeah. It's getting crazy with this slide. Wait till you see the law of syllogism. All right, so the law of detachment states if the hypothesis of a true conditional statement is true, then the conclusion is also true. So if the hypothesis of a true conditional statement is true, then the conclusion is also true. All right, so let's see what it looks like. The easiest way is just to look at it through an example, see how the law of detachment works. Just looking. Got it, Zach?
Yep.
All right. So, use the law of detachment to make a valid conclusion. If two segments have the same length, then they are congruent. Is that a true statement?
Yeah.
If two segments have the same length, then they are congruent. All right, so there's my conditional statement. Now look at this back half of the problem. It says that we know that BC equals XY. Well, what does this mean again? Without the symbol over top?
Line.
Well, without the symbol, it's talking about the
Plane.
length of segment BC and the length of segment XY. So we're talking about the length of them being the same, being equal. Does that match up with my hypothesis?
Yep.
Same length. Is this saying same length?
Yes.
So if these are the same length, what can I conclude about line segment BC and line segment XY?
They're the same. They're congruent.
Then they are congruent. So if this matches up with the hypothesis, then I can conclude the conclusion, which let's write it out in symbols. We can say that line segment BC is congruent to line segment XY. Congruent, equal sign with the squiggle over top. Okay.
It's not exactly rocket science, Brent.
Ooh, that. So make sure we know the difference between the two. This is talking about lengths being equal or the same. This is talking about segments being congruent. Okay, let's look at B. B says, Mary goes to the movies every Friday and Saturday night. How would you write that as a conditional statement? If it's Friday and Saturday night, then
Mary goes to the
Mary goes to the movie. So if I say today is Friday, what can we conclude about Mary? Mary is at the movies.
Besides, there's nothing good going on in the movies this year.
Yeah, there aren't too many good ones, huh?
I mean, most of them are almost horror movies this year.
Yeah. Okay. So the law of detachment. If I say, if Brent talks without permission, then the teacher's going to yell at him. And then I say, Brent's talking, what can you conclude? The teacher's going to yell at
Unless I
him.
have permission.
Okay. If I say, if it is 224, then my period 4 class is in their geometry classroom. And then I say it's 1024. What would you conclude? 1024. You would conclude that
We're not in geometry.
you guys are in, I said
Geometry.
224, I meant 1024, sorry. I think things in my head doesn't come out right. Okay, so law of detachment. Our second law that we're going to get into is the law of syllogism. It's a funny word, yes. Now there's a bunch of lines, so this is just line 1, so give yourself some space. So, it's kind of like a connector. If you have hypothesis P, we're going to have like 3 different lines, so give yourself some space to right below. Then conclusion Q.
Do these letters mean something? Or,
It just helps to organize ourselves. You don't have to remember that they're P and Q. So if I have one conditional statement where I have a hypothesis of an inclusion, and I create a second conditional statement where my conclusion here now becomes the hypothesis. So here my conclusion was Q. If in my next conditional statement that Q becomes the hypothesis, so if hypothesis Q, then conclusion R,
Conclusion on.
what the law of syllogism tells us we can do is I can eliminate the Q part out of both of these and then just combine my first hypothesis with my last conclusion. So if hypothesis P, then conclusion R.
So what?
So you take out the link of both
An
sentences.
example of that.
Yeah, like an example.
So.
Because that's kind of throwing me off there.
We'll go ahead and write that out and I'll give you an example.
What's the date?
The 5th. 10-5. All right, so if Mrs. Crowley goes to a horror movie, then she'll be scared. If she is scared, then she will not be able to sleep. Therefore, if Mrs. Crowley goes to a horror movie, then she will not be able to sleep. Would be your conclusion.
It's full of words. Like, I thought this was math.
Well, yeah, but this is how you, in geometry, we do proofs, and you have to be able to logically write out your proof. So before we get there, we use easier examples, which usually is better in words. Okay, so here we go. If Rick takes chemistry this year, then Jesse will be Rick's lab partner. If Jesse is Rick's lab partner, then Rick will get an A.
So Rick's going to get an A in chemistry.
So what we're looking for is what part is the same in both sentences. Jesse will be Rick's lab partner. Jesse is Rick's lab partner. So since that is the link, we can take that out and take the original hypothesis and combine it with the final conclusion. So I'm going to say if Rick takes chemistry this year, then Rick will get an A. Yes.
How many do you one of those touchscreen pens? It's really hard to use your finger to write words.
I do have a stylus that has like a fuzzy tip on it, but I find it not easier to write with
Really?
it. Yeah.
Why?
My dad has this little thing he plays with Jewel on. He loves those things. He goes through like 2 a week though.
All right, let's do the last one.
What, the stylus?
Yeah.
Why? They break it?
Breaks the tip right off.
If a polygon has 4 equal side lengths, then it is a square. If a polygon is a square, then it is a regular polygon. So, if what, then what?
Oh, so it has the
Where's the link?
4 equal sides.
Here we have, then it's a square. Here we have, it's a square.
So
So if we
all
take
the
out
4
that
equal
part,
sides.
so if a polygon has 4 equal side lengths, then it is a regular polygon. Okay. So, the law of detachment and the law of syllogism. Questions with that?